My name is Russell Jurney. I'm here on behalf of Hortonworks. I'm presenting Agile analytics applications. We go pretty fast, but don't worry if you don't understand something. It's either in the book, which I'm finishing in Poland, or it's also on the website. We've done a lot of examples. My background is actually as an application developer. Before Hortonworks, I worked at LinkedIn. We did in-maps. It was a fun project, social network visualizations of your LinkedIn network. We also did Career Explorer, where I had to predict your next job given what we know about you based on your profile. And at Mean, I did H-based dashboards, visualization, that kind of thing. Before that, I built MySQL apps for casino gaming, so mostly charts to explain why we were making more or less money than we thought. As I said, the book is out. It's actually going to be done while I'm on this trip, so should be out in more like January. You can actually read it now on O'Reilly's website. This is a very opinionated philosophy, but it's not necessarily the only way. If you really like SQL, you may not agree with a lot of this, but I think a lot of the principles still apply. So I'll link you to the slides. So let's start with LOL cats. This slide bombs every time. Nobody laughs, but I'm going to keep doing it until somebody does. So in terms of agile development of applications, that's my background. Since the LAMP stack and then Ruby on Rails inspired a number of frameworks, application development for web apps has actually gotten pretty mature. It's pretty easy to just hire some guys and build a sensible application in an agile way, using Scrum or whatever you like. As soon as you write the code, it shows up on the screen, so you can get users involved and get that rapid iteration going that tends to result in the success of projects. Data warehousing has been around for a while. There tend to be silos. So this guy in this department, he has trouble getting access to this data or this data. And then there's like scientific computing, which has been with us since UNIVAC. It looks very much similar to Deep Blue. It's funny. They both fill a warehouse. It's kind of funny how things are cyclical. So you might define data science as this intersection of three fields: application development, data warehousing, and scientific computing. Some people define it in other ways, but now there's this concept of the data warehouse as a computer. It's actually, though, very tricky, as you probably know, to build warehouse-scale computers out of commodity machines because networks are very slow. There is enormous disk capacity, and Moore's law has continued in terms of chip density, but it's starting to go multi-core, right? 3 gigahertz seems to be about the limit. We're approaching the atomic limits on that. And so Hadoop to the rescue, right? I stole this slide from the CTO, but he stole it from Arun. And so Hadoop is sort of this big data refinery that allows you to use cheap commodity machines in big arrays, and it hides most of that complexity from you. So it's actually pretty easy to use if you use Pig, Hive, or cascading. Compared to storage area networks and network-attached storage, talking about like 3 to 5 cents per gigabyte, as opposed to $1 to $10 for a SAN or $1 to $5 for a network-attached storage. What this means is that with hand-me-down equipment, a department can afford its own cluster, or you can use EC2, or a lot of times a director can purchase a cluster without getting a vice president's approval, and that's a pretty important thing for guerrilla adoption. What this allows you to do, and this usually starts in a guerrilla way, right? You run a SQL query that you're really not allowed to, and you ETL this data warehouse or that data source. You get them on HDFS together. And you start joining things. The silos come crashing down, and you're able to look at your data in new ways that everyone else in the organization that doesn't have Hadoop can't do. Like I said, you're joining like crazy, you're ETLing, it's all really easy. A lot of times, things that took a week might now take a few hours. And it's great, you feel awesome. It's like really powerful. If you stay up at night, a lot of times Hadoop users become nocturnal because the cluster is not as used. You have like thousands of workers on, doing things on your behalf. But okay, now what? What new opportunities does this enable? And so the answer is you can now build entire applications that take advantage of this infrastructure. And so if you look at kind of the skill sets for a data product team, going from customer through like market strategist, a business guy, product manager, user experience, user interaction, and a web developer, kind of hacker to bring things together, and a hardcore researcher. It's an incredibly broad skill set, and I don't know anyone that has the entire thing. So it's sort of an inherently collaborative effort, which means we've got to work well together. But it's very tricky. How do you get insight from data into a product? Right? The back end has gotten thicker, so Hadoop is great, but often it takes some knowledge to make it go. And generating money from insight, like insights people will pay for, from data, can often take 10 to 100 or even longer than it takes to skin that data in an application. And so there's this timeline disjoint that has emerged. And you hear people talk about data science, they're saying, like, how do I get my insights into production? How do I get them into the app in front of my customers? And so it's a real challenge, as I said. And so the wrong way, this is autobiographical, we made a great design, your job is to predict the future for it. Hey, what's taking you so long to predict the future? The users don't understand what 86 true means, because you used Bayes and they don't get it. And you're like freaking out, and the plane runs into the mountain. Which is kind of like how we used to build applications, right, with the waterfall method. You started at requirements, you gathered them, you made a design, and then you implemented. But by the time you got here, the requirements had changed so fundamentally that the customer was no longer really interested in those requirements. And so many, many projects failed, which is why we sort of, the Agile manifesto was written and people started embracing new and iterative ways. Technology changed and software engineering changed to follow it. And so the chief problem is you can't design insight in an analytics application. Like if you pre-specify charts, like the designer makes a chart or your boss is like, I just want to see this or that. More often than not, it's a really bad chart. Nobody wants to see it, people don't click on it, people are quite bored. And so the real way to discover insight is to explore. You're fooling around, this kind of thing. And so a strategy to build good analytics apps might be to make an app for exploring your data. Iterate and publish intermediate results, like whatever your most hardcore researcher did in statistics that day, it's probably a table output, right? You can publish that. So you absolutely have to keep everyone in sync. And you build this app, which can be quite bad in some ways, right? It can be ugly, it doesn't really matter. But it becomes the palette for what you ship in your application. And so we might refer to this as data design. So it's not really the first query that equals insight, it's the 15th, the 150th, the 1500th. And what you really want to do is get things in front of users and they'll go like, aha! Like when we were working on Career Explorer, someone told me to run the jobs for physicists that went to grad school or that didn't. And it turned out, whether they go to grad school or not, they all become software engineers within 3 years, which is really important to know if you want to major in physics. I don't know if that's the same in Poland. Some people call it the Bus Drivers Club of America in the States. It's hard to get a job in physics. And so with Hadoop, it's a batch system, and so it's fairly slow to do 1,500 or 100 or 15 even queries sequentially in batch. And even with a data warehouse, you might wait longer than you want, right? Furthermore, if you're actually sort of thinking about your end user, they'll get much better context inside an actual application. And as I said, pre-designed charts are terrible, but fundamentally, like when you want to start employing like natural language processing, machine learning, when you want to build statistical models, it's very easy to sink a lot of time into the wrong models. It's very easy to define a problem in a dynamic environment in a way where someone spends a year and achieves what you said. Oh, but the problem definition was off a little. That doesn't actually help us. And so a lot of the opportunity, because you actually have to get this into users, is sort of at the intersection of data and design. It's not just predicting things, it's predicting things in a way people will understand, which is a hard design problem. And so given that this is such a big effort, how do we get back to Agile development? And so statement of principles, and then there's real stuff. If you set up an environment where you start with really small insights and kind of snowball them into bigger and bigger insights, every single week, right, your statistician or whoever has to share his data with the team and you have to publish it in the app. You make that interactive like the first thing you do, before you even have your first meeting or whatever. You do not use object relational mapping. You don't transform data between layers. You prepare on Hadoop what you're going to present to the user. So the only transformation might come when you render HTML. And this results in minimal impedance between layers. So everyone can talk about the same thing. And so the scope of that depth of insight grow as you continue to work. And this app that you build, sort of, you discover these aha moments and it becomes the palette for what you actually present to users. Hopefully until the application pays for itself and more. And so the idea is to keep data science teams small, but to train people and to hire people that have broad skill sets. You know, once you have like 4 or 5 people, the transactional overhead starts to dominate. You know, you have to explain it to this guy, who explains it to this guy, and pretty soon the creative process breaks down. That's the opposite of what you want. You often still need in an organization expert researchers. So you have guys that do relevant research, hire them, let them do what they want, and have them as a resource to your generalists. And the point of this is like, building an analytics app is sort of a creative process. So you run it more like a studio than an assembly line. And you have to give a great deal of freedom to explore. Otherwise, you're just not going to arrive at very good answers. That doesn't mean, though, that you don't have deliverables and goals. So you're working towards something. It's just a question of how you get there. And so in Agile data, we value the document over the relation. Relational, like this is an email in raw form. It's exactly like it looks on the screen. And so most data is dirty, semi-structured, or unstructured. This is actually great because it's an opportunity for us to extract data, to extract structure from it. And there's a lot of value in doing so. This is an email that Berkeley Enron set. I can't even figure out how to select it to present how an email looks on the screen to a user. This is me trying in MySQL. I use a bunch of MySQL specific stuff and it didn't quite get me there. And that really obscures sort of what you're trying to do. Which means relational data is probably legacy. Storage is fundamentally cheap, so why should you join? Just project. You can ETL once to document format on import. It's best not to do it in every job. And so obviously it's not always possible to eliminate all joins, but with Hadoop you tend to do far fewer. And so we value imperative languages over declarative. So selecting SQL on data is really good when you're querying it, but when you're sort of refining or generating new data, select doesn't quite fit. You have to select into for one thing, which is not intuitive. Data is dirty, and so the schema is not really there to be effective in SQL. And most of our time we spend munging, which means stepwise data to extract structure. Imperative languages work well there. And so they really fit our way of working with dirty, ugly data. And imperative languages allow you to optimize, whereas with SQL, you're sort of at the mercy of your query planning. So we value the data flow over the select. Here's an example of a data flow in Pig. I think this is the same email to my dad, actually. And so you'll see, like, you have to do, this is a trivial example, but you always lowercase the email address. Some forms capitalize no matter what. So here's a more complete example. I'm hoping this will be the big chart in the book on 2 pages, but they won't let me put it in yet. So basically what I'm getting at is to value pig over high for application development. Pig can consume unstructured data. It's really optimized for a process. It's imperative and inherently iterative. You don't have to specify a schema each time. You simply modify your data and you can then describe it and it will explain the schema. You can use Illustrate, which speeds up development time dramatically. They won a paper, Sigma 2010 or 2011. They sample data, but they also generate data to fit your filters, for instance. So if you have greater than 5, they'll have 6 and 4, and then the next step, they'll show 4 dropping off. Macros are really powerful with Pig. We did an example on the HortonWorks blog for term frequency, inverse document frequency. And so that's like 2 lines to import, which is pretty cool. You can do UDFs in many languages. I think Groovy is just added in .11. And of course, with streaming, you can use like R, Python. I use Python to do SciPy, that kind of thing. And so we can easily prepare our data like exactly as it will appear on our app using Pig. But if you really like SQL, use Hive. It's not a problem. And so one of the principles is at the local level on your machine with a sample and at petabyte scale, we want to be using the same tools, right? We don't want to rewrite our code. At one time, this would have been like a ridiculous requirement, but it is now entirely possible. And so simplicity is essential to scalability. So we use the highest level tool we can. You can easily prepare a sample, like I said. If you have a lot of joins, preparing a sample is tricky because your joins will miss IDs on the join, and you'll end up with no records. Document format, we don't have that issue. Pig, you can run it in local mode on your machine. I do this all the time with Enron emails when I'm writing examples. And then that same code will run on the cluster. Use Illustrate a lot to save you from even running it locally. It's pretty instant. Even if you have UDFs, it'll do the evaluations. So you iterate, debug, and publish locally, and then you run on the cluster and share with the team. Skip object relational mapping. It really doesn't do anything for you here. If you're having to alter your data to put it in your application, then you've generated the wrong data. So you need to all be working together, from the designer to the researcher, to all be talking about the same thing. Because as I said, context, in terms of what the user will understand, is important. And it's often subtle, the semantics of, and particularly predictions, and so don't trust databases, regenerate everything from the files on Hadoop. Now you don't always have to regenerate everything, but it's very comforting to know that, one, your database can die and you can just make another one and recreate your data, but also if you do it this way, you put your scaling in Hadoop, which scales linearly. You don't have to worry about scaling like a real-time app. And this works up to about like every 5 minutes. You can schedule jobs. And so starting from the bottom, this guy Pete Warden came up with this slide, the middle 3 levels, and I extended it. The idea is to start out with simply publishing records, moving up to charts, reports, predictions, and then drive some new kind of action. Like there's got to be a reason you're building the application, and so that is it. You want to enable some new kind of thing for your user. So step 1 is to display atomic records on the web. So like your events, whatever you're analyzing, it could be just about anything. I serialize an Avro because the schema is on board. As a Hadoop user, I've often found data in TSV format, and I don't know the semantics of it. I want to use it, but I don't know what it means. Avro has comment fields. You load it, you don't have to specify the fields. And this in no way, HortonWorks has spent a lot of time on HCatalog. HCatalog does additional things like it aids you into data discovery, like what data is out there that I could possibly use in my analysis. Avro doesn't really help you there, but if you do find lost data, it's incredibly convenient. So to get your data into document format, this is me ETLing the Enron MySQL database from Berkeley and storing it into Avro. There's examples for everything. If you download the slides, there's links. In the book, we serialize our own emails from Gmail. And then the point of the book is for me to figure out a way statistically to get my wife to reply to my emails more often. And then you might ETL logs, right? So these are Apache logs. And so the first thing we do, we have these events, we've gotten them onto Hadoop, and now we're ready to do some stuff. We immediately display those records on the web. So in this case, we're using Mongo Hadoop to store them in MongoDB and Node.js to put them in JSON. But I'm actually not opinionated at all about what stack you use. We've done I think we've done even more than this, examples on the Hortonworks blog. You can use whatever database you want, right? NoSQL, you can use MySQL, Oracle, it really doesn't matter in this model. And there's a bunch of web frameworks there as well. Pig hook up to many, many things, and via hcatalog now, and even an increasing number. So there's a utility cat avro, so in this case, I've avro serialized the Berkeley Enron emails into document format. You can see it's here, it looks like an email, it's kind of what you see in your browser. And so as a data scientist, an analyst, or a designer, you can all look at this data and go, okay, we agree that that is an email, right? And that's pretty basic, but it's also pretty important, right? In this case, that is what you're working with. You're trying to, in this application, extract and mine data from email and present them in some new way. And so from the beginning, you're all on the same page. So load that data in Pig, you describe it. Note the schema is identical to what it was, except there's some peculiarities. Strings become cataways, but it's compatible. You illustrate our events in Pig. Like I said, it generates example data. And then we publish these events to a database. So there's a one-line way to do this. I wrote a simple little script, avro to mongo.pig, which chooses pig parameters. This is what it does. It's basically just loads and stores, and then there's a bunch of stuff to set up. Loading some jars. So then we check our events in the database. This is the Mongo shell. So everything is identical. We picked up an underscore ID. Can't be helped. Now we publish the events on the web. This is Ruby or JRuby would work. It's a framework called Sinatra. So in a few lines, we publish JSON. This is what it looked like in the browser. I think it's a different email, but. So all right, what's the point? So like I said, a designer can now start designing against real data. An application developer can start building his application. The product manager can think in terms of real data, not in terms of some imaginary reality that he invents, which is typical. Everyone is grounded in the same reality. Your data is ugly, right? If you haven't seen it this way, it's worse than you think. You have a lot more work than you thought you did. And you can now start to ship early and often, right? You just ship something, so you're kind of on the right path. And so it feels kind of agile, right? Or at least enables us to be so. If you don't have a designer or a web developer, Bootstrap is incredibly powerful. It's a JavaScript library from Twitter. This is sort of the code to wrap an app. You just load bootstrap.css and then apply these table classes. And then you get like this thing, which is sort of a reasonable start for an app. That's the, I think, Python dump of the data. And so, okay, we stylize it a bit more. We add ID, date, and subject, iteratively improving things. If you add like a reply to, at this point you start linking between documents, so you can go from email to email, you start to get some interactivity. Sorry, I meant to take that out. And so now you make a list of the emails, right? Just like your inbox. This is how you do that in Pig. You group them. That's emails per user, actually. But sure, that works. And then you can actually sort in a Pig group by for each. So if you're using like a pure key value store, this is handy. You can store a sorted list of things, so you can do top things that way. If your database has indexes or a sort order, that's cool. Mongo does, so So you wrap your UI a little more. Now you can go to /emails and start clicking on them, which goes back to your original email page. There's kind of a neat trick. If you have a big enough Elasticsearch cluster, this is all you have to do to make your email searchable. It's pretty cool. It has no security features whatsoever, so it's your job to isolate it behind your web server. But then you can use sort of the same interface you use for your list to search, so it's not too much work to plug in that little search box. We do this in the book, and there's an example on the blog, actually. So we sort of speed up from here, but here's examples. So now we want to create simple charts. So this is a chart of the time of day that I send emails. And then we've given it a little page of its own for my email address. So we start with a table. Start with an HTML table when displaying anything on general principle, because there's probably holes in your data. And so the first thing you'll have to do, like if it's a time series, is to plug in the holes with 0. Try not to expend effort in visualization or interface when you haven't seen the data. It probably looks different than you thought. There's a really cool library called NBD3 that's reusable charts for d3.js. So when we make charts, we're starting to do entity resolution and extract properties from the data. Like if you group by the timestamp, right, you're sort of extracting this time element from the data. If you group by email address, you're starting to extract email addresses which might map to egos or people. And so you start extracting people, places, topics, time series. So as I said, grouping by entities. You start publishing, top N, so top related email addresses. This is incredibly general. This could be anything. And so we fill a page with charts. And so this is how you do top N of anything. Compute your arbitrary rank, probably in some really clever way. And then you can store them into any key value store that way. And just fetching 10 sorted things is really easy for an app to do, so it will scale forever. And again, this is the same structure that's being pushed through all the way. So this is how you would do time series. It's pretty straightforward too. I think in Pig 11 you can do a nested order, but I don't understand the syntax yet. So it's just one operation. And so the neat thing about this is the data is consistent end to end. So say there's 3 or 4 people working on this. Sorry, they have no legs. And but the neat thing is, since the data is consistent, anybody can add a feature, right? What you really want is everyone being creative, and you don't want someone like arguing with someone else that they should add this feature because it's cool. That's what you don't want. You want that guy saying, look what I added in JavaScript. And then you're like, oh, that is actually really cool. And so you push it back as you're able, right? Ticket it, it's technical debt. Maybe you do it immediately. Maybe you have something else to do and you never get around to it. But on principle, so that it scales, you push it back. Here's an example of doing total email account in JavaScript, Python, Mongo, query language, and Pig. And I think there's a real example in the book of like an actual, I think I fill in a time series at each level. And so once you have some charts, once you exceed some threshold of interactivity, once they become customizable, we call that a report. So here's a report on my email address in my inbox. The top related email addresses. It's like my wife, my family, coworker. And then email sent per hour, you've seen that. A neat thing to do, this is so it's actually just, I guess, the mode, but make charts personally relevant to whoever is logged in. People are vain and they tend to like that a great deal. So what it's actually doing, I happen to be looking at my own email box, but it highlights my most common hour to send emails versus theirs. So you can kind of see that stuff. Little tricks like that to get kind of personalization go a long way in terms of engagement. And so the entities that we implicitly extracted when we were doing grouping things for our charts, we now give them entity pages, right? So like /email address goes there. You might have, if you've extracted places, there's a lot of code out there you can grab that does that. You might have /place, that kind of thing, or /topic if you've extracted topics. So they get a type of web page, each entity. Each unique entity gets its own ID after that, so you have its own web page. As they appear in the atomic records, so like emails, you link to them. It's not too hard to do. Once you have them in your key value store, you just grab them additionally. And then you link them together, right? So most related, that kind of thing. And so once you have people clicking, the way you'll link records together will sort of become self-evident. People will say, I wish I could see this in terms of that. Or they'll be like, oh, I get it, this is really neat. But I wonder if, and so you stop having to come up with everything. It's great. So you keep adding visualizations. People want to slice and dice and drill down. You can materialize those views in your key value store and provide them with drop-downs. And so it starts to look like this. We're creating interactive ontologies from semi-structured data. You can start them out, a good way is to start them out with a tag of if you have a user log in, if this is about their data, a tag of just entities they can start exploring, and of course you provide search. And then you've got like entity A with different properties linking to different entities. A problem though that arises when you do it this way, you might filter your base records in a different way for each entity pipeline. And then when they refer to one another, you'll miss a key, right? This is, I've lost weeks and weeks doing this. So as you extract new entities, always try to push back into a common filter. It's worth the effort. So you can see if you don't do that, not found. I think it's 404, not 400. Whereas here you've cultivated a common key set, and the fetch works. And so at this point, you've got kind of built a lot of stuff. And so you get people clicking. That should be as broad an audience as you can have. Sometimes you have to like force your mom to click the app. Other times, people are very interested. That's certainly better. But just keep trying different things, see what's interesting. What you're trying to do are capture those moments, like I said, with the physicists becoming software engineers, where people go, aha, or oh, try this, and it works. And you surface some insight, and people get excited about your app. So now we've got some ammo. We're able to just start thinking about making predictions and recommendations. People will start to wonder, like, for instance, this chart we had about the physicists. That sort of starts to sound like a good prediction. What will the physicists be in 3 years? That kind of thing. But if you look at your web logs and you see what people are clicking, and you just sort of put the computer in front of them or have them use it, a lot of times people will just tell you, I wish this told me this, I wish this told me that. Oh, and so while you're doing this, you're cleaning your data as you go, right? But it's directed at what people are interested in. And so then we get to predictions. And so like I said, we've done a lot of work to prepare ourselves to be here. If you skip steps in the data value chart, so you're like, you have a boss that's just like, I want us to predict this, right? I want to predict the future, I want to do this, but you haven't spent, I don't know, the previous months doing entity resolution and extracting properties and seeing what's there to see what the potential of the data is, see what the low-hanging fruit are. If you just try to make predictions, you're going to have a really hard time. And so if we do it this way, we've extracted entities, their properties, and relationships, and those relationships can start incredibly simply. Like, in fact, I always do just top count, right? Like, I don't even do TF-IDF if I'm doing topics. I just do the most frequent word, because quite often that's pretty good. Then I'll do TF-IDF if anyone is interested. Our charts show us where our signal is rich, even with big data, like petabytes of data. Once you start slicing it down, you get holes in it. So we've done a lot of cleaning to make our data presentable in the charts and in the reports. Everyone on the team by this time, right, you're talking about the data, the app, what you're building, what's possible, and from designer to researcher, everyone's talking about the same stuff. So you're probably functioning fairly well as a team at this point. So we can do things like starting to smooth the sparse data. What I didn't do, there's a note in the book that I should have, is try do a holdout of distributions that are full and compare different smoothing methods and see how well they approximate that holdout with cross-validation. This is Bill Graham. He's a pig committer. He mostly emails at, well, depends which chart you look at. And so we start to look at the data in different perspectives. An email inbox, for instance, from to, there's a social network there. You can apply social network analysis, time series, of course. You can start, calculating the distribution of everything and sort of start to understand your data better, doing natural language processing, and with macros, that's really not difficult at all, even for a guy like me. And you can start to compute conditional probabilities, do naive Bayes is within the reach of everyone, build graphical models. And so this is the point at which we start to sink time into deeper analysis, but hopefully not before this point. Because if we do, we're probably spending it in the wrong areas. And so there's an example of the TF-IDF macro. It's really easy in Pig to compute conditional probabilities, and that's actually good enough, for an initial prediction, right? What is the odds that my wife will apply to me? It's actually 0.13. Usually I'm sending her bills, she texts me. So one of the audience said we should seek counseling. But so that is actually, to a lot of people, probability of reply, you're starting to get to that like magic stage. And I know it's incredibly simple, right? I just took the total and the amounts you replied to and I divided it. But that is, you start to get design challenges at this point. And as you get more sophisticated, they just get harder. And so the point of all this is to enable new kinds of action. So in this case, the action would be, I want to write emails that people will reply to, right? And so there's examples of people that have sort of read this stuff and have followed along and have kind of made apps this way. There's this guy, Michael Baker, in Australia. He started doing full packet capture, and so he has a hard drive hooked up to his, he hooks them up to outbound routers to the internet connection, and because storage is so cheap, he stores every single packet, not logs, like he can recreate any session that goes over the internet. And he uses Pig then to analyze it. And so this is, I think, he's computing a chart for the top severe attacks by country. And then, so this is a little bit past the stage we saw in terms of web development, but it's actually not that far past. He's doing the same stuff, right? He's got his data on Hadoop. He's got it in document format. It's a bunch of just packets that come from Snort. He wrote a loader. He's doing some Pig on it. He's using R streaming, and then he comes up with a record. And this chart is just wrapped around that record. And then this is the Hortonworks data platform they sent me here. And it's pretty cool. HCatalog in particular has a bunch of HTTP interfaces to interact with Pig, Hive, there's Web HTFS. They do training. Any questions?
Yeah, I have a question. You mentioned that at the point of trying to predict something and beyond that point at the top of your little pyramid there might be, if I understood you correctly, some, how to put it, you might start to try to rethink your design, or you may have to start to try to rethink your design because that somebody, like you said, with this cascading method of to present it as a counterpart to this agile data development, that at a very late stage of your development, in the earlier days, when the paradigm or the what client needs changes, and it completely destroys this cascading methodology. And how does this exactly affect the Agile data methodology? So what steps needs to be taken in order to, resolve the conflicts that arise?
Yeah, so I think if your client is paying you to make a specific prediction, so I would like to think that with this you can only regress one step, and you still have a lot of knowledge, insight, experience, and visibility into the data upon which you'll make a prediction. And if you sort of went straight at it, you might not have that. It's pretty tough, I think, when your bill of work is to make a particular prediction. But I would like to think that this would sort of help you communicate better with the client, for one thing, about what is possible based on what they have, because this is essentially a visualization of their data assets. And so it would be then fairly easy to explain why you can or can't do what they want, or why it will take longer, that kind of thing.
Okay, but I was rather getting to that point that, for instance, you're building your top application from the ground up, taking one step at a time, and for instance, at some kind of basic step, you're building your toolbox, you're visualizing the single records, right? You're assembling your tool set. And what if at this point you forgot to, for instance, create one kind of tool, for instance, some kind of aggregation or something like that, and you move along with your process, and at the final stage you just are like, oh, I forgot to do this with this. And how hard it is to just, jump back to that point where you could, and...
So in practice, that will happen every single time. So yeah, I think it's easy. You're at this step, and you're like, and you hop down one, it has to be free-flowing. Or you realize that you need another data set. You have to bring that in. Maybe it's a freely available one. Maybe you have to buy it. Maybe it's something you have to ETL. That would be very, very common. So in practice, you're sort of shifting up and down. And so that would be perfectly normal. The way to know that, though, is to sort of to visualize it. And so at least if you have to do that, you have the visibility of, oh, we didn't do this thing. Like I can look at the app and it's not there, so we should go and add that. And then everyone is then on the same page. Okay, we've done this new aggregation with this new data set, and now let's incorporate it into our predictions.
I have more like a political question, because just last week, if I'm not mistaken, during the Strata conference, Microsoft has revealed its HDSI thing, which is basically what you guys did, but ported to work natively on Windows platform, right? So could you please give us more details about why you guys work with Microsoft, and do you see, a kind of future of Hadoop as a platform working on Windows, right?
Yeah, so they're actually running Hortonworks data platform in that HDN site. I was there when they demoed it at Strata, and it was like seeing Jurassic Park for the first time. When you're like, and I have a dinosaur tattoo. You can hardly see the raptor, so I'm not just bullshitting you. But no, it was amazing. I actually did this prototype like 4 years ago, where I hooked pig to Excel, and it was their interface was incredibly impressive. So they're doing a few things. First of all, now the new version of Excel can handle millions of rows, which is wow. It's like a 64,000 limit or something before it dies now. And then they're hooking to Power Pivot, and they're connecting to Hive. I think they also generate Pig in some instances, their JavaScript framework. To answer your question about Windows and Hadoop, Hadoop now runs on Windows without Cygwin, as does HBase. That was work that Hortonworks helped with. But I think you can absolutely use that for this kind of development. And in fact, I think it's definitely the best interface to Hadoop that's yet been created. I was really impressed. I haven't actually played with it yet, but I'm going to, and be writing about it. But yeah, I think you could absolutely, it's sort of like in the business world, data is not real until it's in Excel. Do you know what I mean? I spent like 3 or 4 years doing companies to try to beat Excel on the web. It's really stupid, don't do that. No, their stuff is really neat. I mean, the fact that you don't have to build an app, I mean, and it just pops in Excel is cool. In terms of sharing, I don't know if it's quite there. Haven't totally used it. But I think you could absolutely adapt this and use the Microsoft Stack HD Insight and do this kind of development. Does that answer your question? Any others?
What is your favorite case study about making money from big data, from Hadoop, from insights? We have no case study in one, so I asked about case study from the US.
Wait, I'm sorry, what was the first part?
Make a case study about making money from big
Oh, I
data,
see.
insight, making money. No insight, money.
Yeah, so people will pay for insight if you pick the right problem domain. They usually won't pay for charts. And if they will, they pay for a prediction based on that chart, way before they would pay for a chart. The first person to suggest that formally was Pete Worden, and I ran with it. That has been my experience as well when I was out selling analytics applications on MySQL 4, really bad idea, to casinos. You know, they were like, the charts are great, but why don't you just tell me what to do? You know, so I think people are really looking for that. My case study of this specifically would be Michael Baker and Packet Loop. He's selling that app at present. I think it's taking off. LinkedIn, where I worked before, certainly does that. Much of their business, in fact, I think at this point they got most of their new users with people you may know. So it started out just friend of a friend, but it's now an enormous string of pig jobs that drives a great deal of their business. They recommend jobs, they recommend groups, they recommend absolutely anything. The jobs directly make them money, but the size of the platform then enables them to sell access to it to recruiters. So yeah, I think probably Flightcaster. I don't know if you've seen Flightcaster. It's irritating. It doesn't work in Europe. They predict the odds that your flight will be on time based on history, weather data, all kinds of things. And I think it's actually just a Bayesian classifier that picks late or on time and then provides a confidence. That's where 86% true came from, actually. I'm never quite sure what it means. So in terms of building an app from data and then selling it, that's a good example. I bet there are many more examples of like the data exhaust, you know, where Facebook or a big site that is a consumer site or business generate a ton of exhaust, and they then feed that back into the product with Hadoop doing this kind of development.
Okay, so I have a second question. We know that big data and Hadoop are hot in some specific area, like government, healthcare, insurance, but they are reserved for big companies. So if you have 3 developers, Java developers, in which industry you will start your next startup?
Would I personally? Gosh, I don't know. I'm trying not to think about startups. I wouldn't do healthcare in the US because I think healthcare is starting to employ Hadoop, and they're particularly interested in Accumula because of its cell level access. There's a regulation called HIPAA in the US that everyone has to sign each doctor's visit so that they won't give out information. It's really complicated. Regulated markets are tough. Hadoop's being used a lot in telecommunications, finance, big companies like that. There's also this concept of medium data, and it's about sort of once you have MapReduce on your data, you're sort of, it's not really about the size, it's about the freedom that gives you. So you're sort of able to break out of the relational database kind of world and just write arbitrarily code to modify your data and sort of mine it for value in any way you want, with any tool you want, and it will scale linearly. So a lot of smaller companies are starting to use Hadoop for that reason. Mostly they're fairly advanced startup types at this point. But that is definitely another use case. So if I had like 100 gigabytes of data, I might well use Hadoop just because it lets me do whatever I want. I'm not really constrained. Does that make sense?
And last question. I see your startup, last startup context about
Next question.
Yeah. What was business model this startup? I'm really interested.
So the business model of Contexa, my friend was really good at entity resolution for address books. Had experience with that, and we just decided that we were going to. I don't know if you've ever like imported your Facebook or LinkedIn contacts to your phone, and then you have like a friend of mine had 12 Russell Journeys in his phone, and so we were going to charge some amount of money to solve that problem for consumers. We didn't think we would make a lot of money doing that. We thought that we would make enough for someone to give us money to solve the problem for business. Like if you have customer lists, you know, like at some point the entity resolution problem becomes sort of intractable. Like Salesforce doesn't really have a good one. We thought that we could solve it well. And based on the data sets we worked with, we kind of did solve it well, but I kept like winding up in the hospital and drama and all that, so we kind of gave it up. There's no shame in failure in Silicon Valley. Anything else? Yeah.
Could you tell more about Agile, big data development, and Cartoon works at Yahoo? For example, what is the difference between teams that work with big data and the teams that doesn't work with big data?
So I think probably because of development of tools like Pig, which Yahoo uses for what, like 90% of its production jobs, let alone its development ones, there isn't as much difference as there was. You know, probably before you would have had, you know, researchers using R or something on their machine for smaller amounts of data. At this point, I use Pig for kind of everything, just because it gives me a provenance record. Like I can use like Bash scripts or Python or Perl or Ruby and stream my stuff through whatever, but in the end I have like a big hot mess. Whereas if I use Pig to do the same thing even locally, it exactly tells me what is happening, and so anybody could like jump in that and figure it out. But in terms of the development at Yahoo, I think I interviewed, I guess, Eric Oldeschweiler, the CTO, and he kind of led the team that turned Hadoop from a prototype into a production tool they run their business on. And he said that it started out just researchers were tired of, they would spend like most of their time trying to get data from different systems, like way back in the data warehouse slide, all the silos. And so they decided to kind of solve it once and for all. And so they kind of got behind Hadoop. After that, I think the key change would have been that they had access to whatever they wanted. They could transform it however they wanted. And there was a lot more freedom and excitement around that. The problem that it's interesting, researchers, instead of sort of shipping papers or just prototypes, they started shipping whole products using roughly the methods that I've outlined. You know, they'll prepare data on Hadoop in the format that it's going to be in the app. You know, so like Yahoo, you know, maybe Yahoo Movies, I use that site. You know, recommend me a film. So a researcher can now do that work and then, you know, push data directly to HBase or whatever they used before HBase. And a web developer can now very easily, you know, put that in the app. So they had this shrinkage of time from, you know, like 6 months or a year or something to do a new product down to as soon as they hear about the product, it's ready to go. And so I think just by shortening the development cycle, things got more agile. But in terms of how they work internally at Yahoo and their actual product process, probably not the guy. But he did tell me that, which was interesting. And I think that that's pretty cool. Yeah?
Are there any existing methodologies, for example, to build the application this way you've just shown us? Because finally, we are all, or nearly all, will be focusing on the customer here. And so just displaying such a way of development for the customer is kind of tricky to grab the money from this. And so the customer is expecting the kind of formal way from the points they are doing the products they want to decide to pay for. And are there any norm? Because there are the existing methodologies like a Prince tool, for example, but it's not a good example to use it in this case. Do you know something about it?
So I'm working on making this more formal as I finish the book. I think in terms of, I did contract work and consulting for 5 or 6 years. I think the way you would use this is to do stepwise deliverables this way, right? So they're saying, we want you to improve our forecasting, say, for something or other. So the first step would be getting the data, all in one place that you require, and then you could display it as your first deliverable. You could then work with them. I mean, you can do a lot of this up front. You work with them to, display some charts that, that would indicate you're on the path. And if it's interactive, you might get in the good situation of the customer sort of saying, oh, well, I thought I wanted you to do that, but in fact, this chart's great. Bob, the CEO, loves it. Can you do that instead? And so you sort of, if you have the customer involved with this kind of stepwise stuff, hopefully it can help you to be agile, even on contract work. Admittedly, it's definitely harder. I've sort of argued that this should work like a design studio, and ideally it should. But if you're proposing deliverables, hopefully this will help you sort of tweak them as you go.
Also, in my opinion, also, if I'm observing this, that's kind of I can remind myself, for example, that the web services, yes. Once everybody's, for example, aware of how to write a web service, it's a kind of explosion inside the organization of web services. And after then, the people are starting to look for things like how to govern this, how to secure this,
How to find them,
find them, how we can find, for example, those secure services are doing the same things, for example, and that's it. And so that needs kind of an orchestration, in my opinion.
Thank you. That's excellent. Anyone else?
And do you have any, let's say, private project at Yahoo or Hortonworks that you plan to open source in the nearest future?
Everything at Hortonworks is open sourced. They don't hold back one line of code.
But maybe they are publicly available, but they are not at Apache Incubator or Apache Developer Project, and there are plans to move this project to gain bigger audience.
So I know if you might not have seen, everyone might not have seen the Ambrose project from Twitter. It's not Apache. It's pretty interesting. They do like a force-directed layout of your pig job in a web app, and you can kind of monitor it, and it'll tell you why it failed. That's pretty neat. There's a new Avro storage loader for pig that Joe Adler at LinkedIn has created. It's probably going to replace the existing one. It has Trebney support, which is cool. It's a column store based on Avro. You might have heard about it recently. Let's see, there's actually a ton of stuff on GitHub for Pig that most people aren't aware of. That's the basis of a lot of the blog posts that I linked to. Pig actually hooks to pretty much any late model NoSQL-ish store. It's cool. Are you looking for like secrets about what Hortonworks is going to do? There's a string of interesting stuff, but mostly we work in the open in terms of open source. So it's usually in the gyres. Yeah, they're very strict about that in terms of the projects. So high availability for Hadoop 1.0 is something that's fairly Red Hat and VMware. They're able to do high availability without using Yarn. That's pretty cool. Yarn continues to develop. One thing that really interests me lately is Shark. There's been some interest lately in lower latencies in querying stuff on HDFS. Shark can get like, so with Shark you can use Hive and then you can do a single command and cache the entire table in RAM. And so that obviously depends on you having enough RAM, but if you do, it's, you know, like it can be 50 or 60 times faster. Even if you don't, it can be like 10 to 20 times faster. Shark is based on Spark. It's sort of language that does a lot of caching to allow iterative, like machine learning stuff, that kind of thing. That's of interest. And with Yarn on Hadoop 2, you can kind of run that stuff concurrently, although there are real challenges with scheduling that no one has quite resolved yet. It's sort of up to the framework to do so, and I don't know that any of the Yarn customers really do. So you sort of end up having competing resources in prod. But in development, you know, Shark is awesome. I'm going to be writing about that. I'll do, you know, some pig stuff, and then what always happens is, okay, you've done your pig transforms and it looks okay, but like what actually got created? You want to then query it 10 or 20 times to check the distributions, just sample some data, sniff check it. I'm going to be loading that stuff into RAM and querying it with Shark, so it'll be like instant. Whereas pig can take, you know, depends on your data, but a few minutes at least. Yeah.
The traditional, I guess, BI approach, say, setting aside the big data issues you might have, to say you have the open source other groups like the Pentajos or those guys in the world, they're obviously trying to show their way to be agile with their tools as well. And if you were analyzing a smaller data set, let's say even if there are tens or hundreds of gigabytes of data, where the traditional approach, where you could throw up, you could climb the pyramid in a similar way with against the Microsoft Analytics server or whatever. You could climb the way up that way. Do you see a difference in how you can analyze the data in that world versus how the tool set you have with
yeah, I think
versus that tool set, the traditional tool set.
So with less data, you have the option of querying on the fly, which makes things, you can utilize that feature. At this point though, given the challenge of, I guess it depends on what you're doing. If you're making predictions and doing forecasts and things, I would probably prepare the results I was going to display in the web app using like whatever SQL Server, whatever I was using. I would probably output records in it anyway. And I know that's probably unusual, but again, I think that sort of everyone acting on the same data is important.
Versus transforming it into some other...
Yeah, ORM and that kind of thing. I think that's obscurity, and it's obscurity that you don't need anymore. Yeah.
So one of the key advantages of this approach is you can keep the terminology used, but just keeping the model consistent throughout.
Yeah, you remove all the impedance, right? Like
emails and emails.
Yeah, you remove all of the impedance, and that can kind of bring people together that have diverse skill sets. You know, you might have like an artist that's actually just an artist, and he knows CSS, you know, and that guy, or a little bit of JavaScript. You know, and that guy's going to have a fundamentally different view than the guy that's actually a researcher at a university working in the private sector. You know, maybe you're the guy in between. You want all those perspectives kind of working at the same time, and so if the data is consistent, everyone can kind of add a feature. And you can have conversations about the data, and you're not going to get the designer going, well, is this there? Can we do this? You know, it's like, well, you've seen the data. What do you think? Does that look easy? Does that look... I think there's value there. But I've been sort of working with data for so long that sort of those traditional tools aren't an option. That haven't given it that much consideration. But I will. Thank you. Yeah, I mean, I think definitely tools like the HD Insight stuff. If you have smaller data that you're already doing a lot of analysis on, like with SQL Server, now you can kick extra jobs out to Hadoop. I don't know that I would replace all that SQL Server stuff. But yeah, there was probably stuff in here you could use.
But so, taking to the point, for example, you as a Hortonworks employee, for example, how you can see place for the Hadoop stack, or everything which is around Hadoop, and just a pure commercial structure, for example, like we have now the data warehouse and all the ETLs, all the reporting stuff and so forth. Where it is exactly.
Where would Hadoop start? Yeah, so I'm writing a white paper on this. It's a secret. I keep trying to get people to read it because I want someone else internally, but it's easy to read email, it's hard to read documents. I have like 25 open and I'm like, yeah, I'll get to them. Yeah, so I think I outlined like 4 steps. The first is just playing around, right? Like learning, and the second, I interviewed Eric, the CTO, about this, and it's basically Hadoop starts out anywhere you can't solve a problem with what you already have, and Hadoop allows you to do it very cheaply. So you have some ETL that you just your Oracle or whatever. Some names I shouldn't say now. Whatever your budget is, usually if it's not open source, you pay a great deal. And even if it is open source, often if it's on like a storage area network or whatever, it's a hardware price associated with it. So I think there's a lot of tasks. ETL is a real sweet spot where you can offload some of that processing onto Hadoop, and Hadoop could be like 5 machines, and all of a sudden you can do that task that your boss wanted you to do that you couldn't otherwise, and maybe they're hand-me-down machines, or you do it in the cloud, or you get like a $5,000 purchase order for some, whatever. So it's basically, and the key thing to do there is to get a win. Do you know what I mean? Like, don't pick something that's very difficult. If you want Hadoop in your organization, pick a task that everybody wishes you could do. Like there's these things that people complain about in every company, university, everything. I wish we could just, and so cheap data processing, if that can enable a fix for that, that would be the thing that I would start with. Usually then people will say, oh wow, that was pretty cool, what else we can do with it, or can we do with it? Then a bigger check gets written, you get more machines, you start doing, pulling in data from multiple sources like I talked about, and at that point everybody kind of wants access. You start doing things in your department nobody else can do, just by virtue of being able to ETL things together, and you start producing neat stuff, and other departments, other groups are like, whoa, we want access to that, and you're like, whoa, we only have like 10 machines or 20 or whatever, or 100, and then a bigger check gets written, and it sort of spreads like a virus. And it's good because it's fundamentally cheap. It's direct storage going to a processor. They do that efficiently with MapReduce, and so any way you can get it in to solve some small problem, that's the way. And then it grows like a virus. Anyone else? Well, the other way, a lot of people want to play around with like natural language processing or sentiment analysis, and Hadoop's a really easy way to apply R or Python over a lot of data.
Yeah. I was also interested in talking with my colleague, and he said, for example, there are 3 M's in this business here. One is a mean time to recover, mean time between the failures, and mean time before the secure will come to the software you are developing. Yeah.
So that's a
Yeah.
That's I mean, obviously there's a pitch to be made for reliability as well. It's weird, you just stop worrying about it, Sometimes the cluster is slower because a node has died and it's redistributing those blocks, but it's really neat having a system that sort of heals itself. Anyone else?
Do you see any next step in this business? I think what will happen from your experience, for example, observing this business for a couple of years, and a prediction?
I think more and more organizations will start adopting Hadoop. I think the next big trend is kind of the data science thing, which is kind of enabled by access to data, which is again connected with Hadoop. I think you're going to see like every manager wanting to predict, rigorously predict, some set of goals for next quarter, that kind of thing. Real time is a big trend. There's still that 5 minutes between your batch job and right now. So you're seeing systems like S4, the one from Twitter, what's that called? Forget. Somebody knows it.
Storm?
Yes, Storm. I often just use queues, but that's not very cool. And there are some others, but I think a lot of people want those sort of whether they need them or not. So that's a kind of hot right now. I've been there 2 months though, so I don't have that many predictions. I know it's actually been fairly strange. I came from the internet sector, and everyone, like there are probably a dozen internet companies with 1,000 node or more clusters at this point. They adopt things very, very quickly. It's been sort of a wake-up call. The enterprise is much more careful in its adoption. And so I think you're going to see the transformations that happen in the internet space with, every, hot startup, having some cool data-driven features on their site with kind of every website, every company, every, that kind of thing. So I think that probably the internet sector is a good predictor. Anyone else? Okay, well, thank you.
Thank you.